Good morning, class. We are looking at chapter 3, derivatives. Here, section 3.5, the chain rule, second part, implicit differentiation. Derivatives and rates of change. The derivative as a function, basic differentiation formulas, the product and quotient rules, the chain rule, and now the second part of it, implicit differentiation. Various differentiation formulas, such as definition, dy dx is limit of delta y over delta x as delta x approaches 0, or f prime of x is limit of f of x plus h minus f of x over h as h approaches 0. The derivative of x is 1. The derivative of a constant times f of x, you can take the constant out. The derivative of the sum is the sum of the derivatives. The derivative of the difference is the difference of the derivatives. Various basic differentiation formulas, such as a constant gives you 0, power rule, x to the power of n is n, x to the power of n minus 1. Exponential function is itself, sine is cosine, cosine is negative sine, and the rest of the trigonometric functions. Product rule, fg prime is f prime g plus g prime f. Quotient rule, f over g prime is f prime g minus g prime f over g squared. These are short hand notations. A composite function f of g, or f of g of x, when we want to differentiate, we get f prime of g of x times g prime of x. In Leibniz's notation, dy dx is dy du times du dx. Also, in the case of an exponential, we said, in general, the derivative of e to the power of x is itself and anything involving e, or any exponential. However, if it's e to the power of kx, by the chain rule, the same thing times k. If it's e to the power of g of x, the same thing times g prime. And it's b to the power of f of x, by the logarithmic properties, besides itself, b to the power of f of x, we need ln b, and by the chain rule, we need f prime. And now, the chain rule, part 2, implicit differentiation. Functions expressed by one variable are defined explicitly in terms of another variable. Y equals x squared minus 2x plus 1 is an example of that. In general, y equals f of x. Some functions are defined implicitly by a relation between x and y, such as x squared plus y squared equals 25, or x cubed plus y cubed equals 6xy. In some cases, it is possible to solve such an equation for y, and in some cases, it is not easy or even impossible to do so. In such cases, we can use the method of implicit differentiation. This consists of differentiating both sides of the equation with respect to x, and then solving the resulting equation for y prime, or dy dx. Here's a simple warm-up example. We want to differentiate 4x plus 2y equals 10, and we're going to do it both by explicitly and implicitly methodologies. And so explicitly, we simply solve for y, meaning I'm going to move the 4x, make a negative on the right side, divide everything by 2, y is negative 2x plus 5, and we know the derivative y prime or dy dx is minus 2. Implicitly, that means differentiate as it's given. So what is the derivative of 4x? Is 4. But what about 2y? Y is like g of x. The derivative of g of x is g prime. The derivative of y is y prime, or dy dx. So this is 4. This is 2. Dy dx, or y prime, any number, results in 0 when you differentiate. Now, on purpose, I'm writing dy dx because I want to mention that when the independent variable is x, dy dx and y prime are interchangeable. So I'm going to move the 4, make it negative on the right. I'm going to divide both sides by 2, and dy dx is equal to negative 2. Again, dy dx or y prime makes no difference. Given the circle x squared plus y squared equals 25, find y prime. Bear in mind, this is a circle centered at 0, 0 with the radius being square root of 25 or 5. So we should know that. To find y prime, the solution is to write this and differentiate it implicitly, differentiate both sides. Of course, you can solve for y. This is not difficult, it's doable. But it's easier to differentiate it implicitly. To do so, of course, x squared is 2x. But what about y squared? Think of it as the extended power rule. What is the derivative of g of x to the power of n? N g of x to the power of n minus 1 g prime. So what is the derivative of y to the power of n? Is n y to the power of n minus 1 y prime, just like the extended power rule. So this is 2x, this is 2y, y prime, any number results in 0 when you differentiate. Move the 2x and make it negative on the right. Divide both sides by 2y, and y prime becomes negative x over y. Find an equation of a tangent line to the circle at the point 3, 4. Tangent line, or any line, requires 2 pieces of information. A pair x, y, which is given, and the slope. This is not the slope yet. When you plug in given 3, 4, x must be 3, y must be 4, plug in becomes the slope. So m, the slope is negative 3 over 4 when we plug in. Y minus y1 equals m times x minus x sub 1. Y minus 4 equals m negative 3/4 x minus 3. Distribute. Negative 3/4 x plus 9 over 4. Move this, make it positive 4. And positive 4 is the same as 16 over 4. With 9 over 4 becomes 25 over 4. Find dy dx of y prime, step by step. X cubed, 3x squared. Y cubed, ny to the power of n minus 1 y prime. So 3y squared y prime or dy dx. 6xy, we notice if we put a raised dot, that means we are looking at f times g, and therefore we need the product rule. 6x, the derivative is 6 times g, which is y. Y, the derivative is y prime, or we use dy dx. times f, which is 6x. And now we are done with calculus. We're going to solve for dy dx. To do that, we're going to keep this intact. We're going to move this to the right and make it negative. We're going to move this to the left and make it negative. We want to factor the dy dx out. We notice there is also a common factor of 3 on the left as well as the right. So if you take the 3 dy dx out, this gives us y squared. And this gives us negative 2x. And this one, you simply just take out the 3. You get 2y minus x squared. To divide both sides by this, we just first drop the common factor of 3. Then we divide this one by this one, and that's dy dx equals 2y minus x squared over the coefficient of dy dx, which is y squared minus 2x. Four x squared y plus 2y squared equals 18. We want to differentiate this, and the first thing we notice, this piece is the product of 4x squared and y, or you can keep the 4 out, either way. We are going to use the product rule on this. F prime g plus g prime f. F prime is 8x times g, which is y, plus g prime, which is y prime or dy dx, times f, which is 4x squared. So that piece, 4x squared y, is differentiated into 8xy plus y prime times 4x squared. Now, this one, we use the derivative of y to the power of n. This one, 4y, y prime, and any number results in 0 when you differentiate. These two involve y prime, we keep them together. This one moves, becomes negative, and this two, we can take out the y prime. However, we notice 4 is in common also. If you take the 4y prime out, this gives you x squared, this gives you plus y, and the right side minus 8xy. So divide the right side by 4 times x squared plus y, and this goes away. This changes to negative 2. So y prime becomes negative 2xy over x squared plus y. Or x squared plus 6y plus y squared equals e. We want to differentiate this term by term. The first one is 8x plus 6y becomes 6y prime, y squared 2y prime is a number. Its derivative is 0. We keep this 2, we move the 8x. When we keep this 2, we can take out 2y prime as a common factor. We get 3 here, y here. As I mentioned, 8x is negative on the right side. Again, you can drop the 2 from both sides, meaning this goes away and this becomes minus 4. And now on the right side, minus 4x divided by 3 plus y. That is y prime, everybody. All right. X e to the power of y plus 2y cubed equals 3x. We want to differentiate. We notice this is the product of x and e to the power of y. Again, using the product. F prime g plus g prime f. F prime is 1 times g, which is e to the power of y. Now, e to the power of y, exponential is itself. So e to the power of y. But remember, e to the power of g of x is e to the power of g of x times g prime, and y is like g of x. Therefore, e to the power of y, y prime times x. 2y cubed, following the extended power rule. 6y squared y prime, and 3x is simply 3. We're done with calculus. We are going to solve for y prime, which means we're going to keep these two. We're going to move this one, make it negative. In other words, 3 minus e to the power of y on the right. And this one, we're going to take out the y prime as a common factor. Then we are left with this 2, which is x e times e to the power of y and 6y squared. Divide both sides by the parentheses, and y prime becomes 3 minus e to the power of y over x e to the power of y plus 6y squared. Either y prime or dy dx makes no difference. We want to find an equation of a tangent line to x squared y squared equals 1 at negative 1 comma 1. Tangent line, as always, we need a pair x comma y, which is given, and we need the slope, which means differentiate. To do so, we notice it's the product of x squared and y squared. The product rule is used. F prime g plus g prime f. F prime is 2x times g, which is y squared, and g prime y squared, extended power rule, 2y y prime times x squared, and the right side is a number 0. To solve for y prime, let's move this one to the right and make it negative. So this becomes negative 2xy squared. And this is y prime. You want this one, you're going to divide by 2yx squared. So the 2 goes away, negative sign remains. The x goes away, and the exponent 2. The y goes away, and the exponent 2. We end up with negative y over x. This is the derivative function, y prime or dy dx. Now, what is the slope? Plug in. M is y prime evaluated at the given pair negative 1 and 1. You plug in, minus y becomes minus 1, x is minus 1. Minus 1 over minus 1 is positive 1. Y minus y1 equals m times x minus x of 1. Y minus 1 equals m, which is 1. X minus negative 1 makes it x plus 1. So the right side is x plus 1. And you move the negative, make it positive 1, and 1 is positive 2. So y is equal to x plus 2.